Hello. Today we're going to talk about the binomial approximation. To do this, we're going to visualize the PDFs for the Poisson and the binomial distribution. Now the binomial distribution has two parameters, n, the number of trials, and p, the probability of success. So we have two sliders here to help change those values. So here is the PDF for the binomial distribution. As we know, the binomial distribution and the Poisson distribution are discrete random variables, but we're going to display them today with a continuous smooth curve. As you can see, this is the typical symmetrical curve, and this would be a typical question. So for example, flipping a coin with a probability of 0.5. And here is the equation for the PDF. Here's the combination in front, and then we have the probability of success and the probability of failure. And we can change n and p. You can see kind of how it changes. And we can shift it around. So again, we want to find a good approximation for the binomial distribution. We already know we can approximate it using the normal distribution, but what about the Poisson distribution, as the Poisson is also discrete? Now, for the binomial distribution, we have these two parameters, n and p, but for the Poisson distribution, there's only one parameter, m. And for the Poisson distribution, the expected value is m as well as the variance. So we know the binomial distribution expected value is n times p. So what if we set the m value for Poisson to be n equals n times p? So then they have the same expected value. So here we have m equals n times p, and here will be the PDF for the Poisson distribution. Again, we have m to the x times e to the minus m, all over x factorial. And again, we can change it around. And we can kind of notice that it looks kind of similar to a binomial distribution already. So our goal will be to find out when does it match. So if we show both of these, as we can see here, it doesn't match very well. And if we increase n, decrease n, it doesn't change it too much. What about p? What if we change the probability of success? So it seems as p gets smaller and smaller, it seems to be closer and closer to the binomial distribution. And it seems as the p-value is, about 1 or 2%, it's almost exactly the same. As we change n, it still looks about similar. So as we can see, it should approximate the distribution when p is very small. This makes sense as well, since we know for the Poisson distribution, we need the probability of success for a given interval should be very small. So we can approximate the binomial distribution with the Poisson distribution when p is a very small number. Next, we'll prove this. Thank you.